So in this video, we are continuing to look at the solutions to an old test that you took. So the next question is, write an equation of a cosine graph with a phase shift right 3, a period of 5 pi, a vertical translation down 6 units, and an amplitude of 3. So we know that we're going to have some equation in the form y is equal to a cosine bx minus c plus d. So a, the net coefficient in front of the cosine function, and this is our amplitude. So we're given in here that the amplitude was 3. And so we know that our a value in here is 3. So we can rewrite this as y is equal to, our amplitude is 3, so 3 cosine of bx minus c. The vertical shift, I know, is what we're adding or subtracting outside of the function, and it told me that we have a vertical translation down 6 units. So I know my d value here is equal to -6. So we're going to have -6 in here. So we need to figure out what our coefficient b is and our constant c is. Recall that a period, the length of the period, was equal to 2 pi divided by b. We're given what the length of our period is here. We're given that our length of our period is 5 pi. So we know that 5 pi then has to equal 2 pi over b. So let's solve for b here. We could multiply both sides by b, so we get 5 pi b equals 2 pi. Divide both sides by 5 pi. We get b is 2 pi over 5 pi. The pi's cancel. We're left with 2/5. So far we got y is equal to 3 cosine b, which is 2/5, x minus c is equal to -6. So we just need to figure out what our c value is. Recall that phase shift the formula for the phase shift was c divided by b. So here we know that our phase shift, it tells us, is 3. So we have 3 is equal to c divided by b. But we just found what b was. B was 2/5. So we could get what c is by multiplying both sides of this equation by 2/5. So we get 2 times 3, so this is 6/5 is equal to c. So y is equal to 3 cosine of 2/5 x minus c, so -6/5. And then that was the argument. Outside of the argument is our -6. So we found the equation of that cosine function given the information about its graph. So let's now look at the next example. The next example says, let's find the exact value of each expression. Do not use a calculator. So we have sine of 20 degrees all over cosine of -70 degrees. Well, first of all, I notice that I have cosine of a negative angle, and I know that cosine is an even function. So I know that cosine of a negative angle theta is the same thing as cosine of theta. So let's rewrite this as sine of 20 degrees all over cosine of 70 degrees. So recall that cosine of 90 degrees minus theta is equal to sine of theta. And so if I look at 90 minus 70, that's the same thing as sine of 20 degrees. So our cosine of 70 degrees is equal to sine of 20 degrees. So let's just rewrite this really quickly as sine of 20 degrees all over sine of 20 degrees. So doing that, we get that this is equal to 1. And then for part B, we have 2 sine of 110 degrees theta times cosecant of 110 degrees. So let's just rewrite this. Let's rewrite cosecant in terms of sine. Remember, cosecant of 110 degrees is the same thing as 1 over sine of 110 degrees. And so notice our sine of 110 degrees cancel, leaving us with 2. Okay, so now we're looking at solving trigonometric equations. We're looking at solving sine x plus root 3 equals negative sine x, and we're looking at all possible values in radians. And so if you have a trigonometric equation, and I notice that this is linear, we want to isolate our trigonometric function on one side of the equation, get everything else on the other side. So if we subtract sine x on both sides of our equation, we get that root 3 is equal to negative sine x minus sine x is negative 2 sine x. Let's isolate sine x by dividing through by negative 2. So we get sine x is equal to root 3 all over negative 2, or negative root 3 over 2. So let's ignore the negative for a second, and let's just think about the angle x in the first quadrant. Sine of what angle gives us back positive root 3 over 2? Well, that would be 60 degrees or pi thirds. And so I know my reference angle is pi thirds. And so now let's think about where sine of x is negative. Well, sine of x is negative in quadrant 3 and in quadrant 4. So using pi thirds as our reference angle, we have pi plus pi thirds. So that is x is equal to 4 pi thirds. It wants all possible values. So we're going to add plus 2 pi k here, where k is an integer, because we can make a full revolution from 4 pi thirds, or multiple revolutions from 4 pi thirds of 2 pi to get there. And so if we're looking at the other quadrant where pi thirds is our reference angle, that is 2 pi minus pi thirds, or 6 pi thirds minus 1 pi thirds is 5 pi thirds. So the other value x can be is 5 pi thirds plus 2 pi k. And so we talked about before, integers could be rewritten with that funky kind of z looking figure. So now looking at the next equation, we have 2 cosine theta sine theta equals sine theta. I noticed if I set this equal to 0, I could factor out a sine theta. So let's go ahead and do that. So let's subtract sine theta on both sides of our equation. We would get 2 cosine theta times sine theta minus sine theta is equal to 0. So now factoring out what we have in common, the sine theta from both of those terms, we're left with 2 cosine theta minus 1 equals 0. So setting each factor equal to 0, we can solve. So when is sine theta equal to 0? And when is 2 cosine theta minus 1 equal to 0? So thinking about when is sine theta equal to 0? Sine is our y value on the unit circle. So it's equal to 0 when we're on the x-axis. So when theta is equal to 0 and pi, and it wants just values between 0 and 2 pi, not including 2 pi. Now we want to look at when is 2 cosine theta minus 1 equal to 0. So let's add 1 to both sides and then divide by 2. That would be when cosine theta is equal to 1/2. So I know cosine theta is equal to 1/2 when theta is 60 degrees, or pi thirds in this case. So theta equals pi thirds is one of them, but we also have to think about where cosine theta is also positive, not just the first quadrant, it's also positive in the fourth quadrant. So treating pi thirds as a reference angle, 2 pi minus pi thirds is 5 pi thirds. Okay, so we found our solutions to this equation. Part C says we have sine of theta divided by 3, and then minus pi fourths. We want to know when is this equal to root 3 over 2. And we want to find all possible values in radians. So let's take our argument, which is theta over 3 minus pi fourths, and let's rewrite that as A, capital A. And so if we do that, we can rewrite this as sine of A, capital A. We want this to equal root 3 all over 2. And so let's first think about our angle A. What angle A of sine gives us back root 3 over 2? Well, that is 60 degrees, or pi thirds. So A is going to have to equal pi thirds. That's the first quadrant. It says all possible values, so let's add our 2 pi k in there. Or capital A is equal to, well, sine is also positive in the fourth quadrant, not the fourth quadrant, I'm sorry, in the second quadrant. Sine is positive in the second quadrant. So that's pi minus the reference angle, pi thirds. So 3 pi thirds minus 1 pi thirds is 2 pi thirds plus 2 pi k. But we didn't want to know what A was, we wanted to know what theta was. So let's go back and look at our substitution. Our substitution here was theta over 3 minus pi fourths is equal to pi thirds plus 2 pi k. And then we also have over here this theta over 3 minus pi fourths is equal to 2 pi thirds plus 2 pi k. So getting theta by itself, let's add pi fourths to both sides of our equation. I need a common denominator. My common denominator here I can see is 12. So I have theta over 3 is equal to, well, 4 pi twelfths plus 3 pi twelfths is 7 pi twelfths, just getting a common denominator, plus 2 pi k. Multiply both sides of our equation by 3, we can get theta by itself. So we get theta here is equal to 7 pi twelfths. Well, 7 pi times 3, clearing our fraction, is that's 21 pi twelfths plus 6 pi k. That reduces a little bit. 21 and 12 have 3 in common, so this gives us 7 pi fourths plus 6 pi k. So let's do the same thing for our other equation. Let's get theta by itself. We would add pi fourths to both sides. So we would get theta over 3 is equal to, again, a common denominator is going to be 12. So that would be an 8 pi 12ths plus a 3 pi 12ths is 11 pi 12ths plus 2 pi k. Clear our fractions, multiply both sides of our equation by 3. We get that theta is equal to, okay, well, 3 distributed over here reduces with my denominator. So this would be 11 pi 4ths plus 6 pi. Okay. So all solutions for theta are given there. Okay, so number 9, how long must a ladder be to reach a window 50 feet above the ground if the ladder is resting against the building at an angle of 45 degrees with the ground? Okay, so we have some building. We want to reach this window. We have a ladder that is going up here. We want to reach it. We know the angle with the ground is 45 degrees. We know that the height of that window is 50 feet. And we want to know how long must that ladder be. So that is our hypotenuse. So looking at our angle of 45 degrees, we're looking at, we know the opposite, and we want to find the hypotenuse. So that should clue you in that you're going to use your sine function. So we have sine of 45 degrees equals the opposite, 50, over our hypotenuse, c. Multiply both sides by c. We have c times sine of 45 degrees equals 50. Let's divide both sides by sine of 45 degrees. So we get c equals 50 over sine of 45 degrees. If you wanted to, you could have evaluated that first. So we get c is equal to 50 divided by sine of 45 degrees, which is root 2 over 2. So division with fractions, copy the first number down. So 50 times the reciprocal. So that's going to be 2 over root 2. So 100 over root 2, rationalizing our denominator, multiplying this by root 2 over root 2. This is going to give us c is equal to, well, 50 times 2 is 100, root 2 all over 2. So we get c is equal to 50 root 2. And we're in terms of feet. So you don't have a calculator, so we're going to leave it in that exact form. So the length of our ladder needs to be 50 times root 2 feet. Last problem. You're in a blimp that is 4,280 feet above the ground. You spot your house from the blimp. You measure the angle of depression of 24 degrees from its horizontal line of sight to the base of the home. Assume that the ground is flat. How far away along the ground is the house? Okay, so congruent angles. I noticed that my angle in here, theta, is 24 degrees. And so we are going to look at this, and we are going to look at our angle. We know the opposite, and we want to know the adjacent. And so in this case, we have tangent of 24 degrees is equal to the opposite, 4,280, over our adjacent x. So let's multiply both sides by x. X tangent of 24 degrees is equal to 4,280. Divide both sides by tangent of 24 degrees. We get 4,280 divided by tangent of 24 degrees. 24 degrees is not one of our special angles. And you weren't allowed to use a calculator on the test. And so I had told the class to leave it in exact form. And so They're 4,280 feet divided by tangent 24 degrees feet from their house along the ground. Okay, so hopefully going through these solutions was helpful. You saw where you went wrong when you took this as a practice exam, and understood where you need to study and work on problems before the exam.